Hello, your dear viewers. Thank you for tuning in again. Today we are going to look at aromatic compounds. We are very sure that most of us know these compounds, but we have to look about what it takes for a compound to be declared to be an aromatic compound. Most of us often confuse them. So, these are chemical compounds that consist of conjugated planar ring, a ring system with conjugated delocalized pi clouds, or the delocalized pi electron clouds, we can call them the alternating double and single bonds. So these compounds, first of all, we are saying the main words here are planar, a ring, and conjugated. So that is what most of them must have, but we should not forget that we can have compounds which have these qualities. They can choose to be aromatic, non-aromatic, or anti-aromatic. So we are going to look at some of the rules or conditions that a compound should have in order to be considered an aromatic compound. The first one is cyclic. The compound is supposed to be cyclic. That means the atoms are supposed to make a circle or a ring. Then those compounds should form planar, that at every atom, the system there should be sp2 hybridized, or we should have a planar system. And it means all atoms in that molecule should be on the same plane. Then fully conjugated electron system, that is alternating single double bonds or pi electrons being conjugated in the system of the ring. Then the most common one which qualifies was the rule which was created by Huckel. That is the Huckel's rule, which is known as the 4n plus 2 pi electron system rule. The 4n plus 2 pi electron rule gives us the total number of pi electrons. So every molecule which will conform, or the total number of pi electrons which conform to the 4n plus 2 pi electron rule, then we shall call that this one is going to be an aromatic compound. As we can see, our examples of aromatic compounds, first one, or the best example we all know, is benzene. So when you look at this structure of benzene, it is cyclic, it is planar, it is conjugated. As you can see, the double bonds are alternating, double single. Then when you count the number of electrons, we can see when our n in the equation is 1, it gives us a total of 6 pi electrons, and those are the electrons which are present in the benzene ring. So benzene qualifies to be an aromatic compound. The next example is naphthalene. So when we look at naphthalene, it is also cyclic, though it has 2 rings joined together. It is a bicyclic compound. So it is planar. Each and every carbon atom is having an sp2 hybridization. The bonds are conjugated throughout the whole 2 rings, and it obeys the 4n plus 2 pi electron. When n is 2, it gives us a total of 10 pi electrons. Next, we are looking at a cyclopropyl ion, cyclopropyl ion. It is also cyclic, 3-membered ring. It is planar, and it is conjugated. So when you look at this, at one end it has a positive charge. So here we have only 2 pi electrons, and since the other side means the carbon is electron deficient by 1 bond, so it means that bond also at that point it is a planar, it is sp2 hybridized. So when you count the number of electrons, we have 2 pi electrons, and here our n is 2. Then we have other examples. These are heterocyclic compounds. When we talk about heterocyclic aromatic compounds, the ones whereby the other positions can be substituted by other atoms other than carbon. So when you look at pyrrole, we have nitrogen, a 5-membered group. So in these compounds here, the red dots, these ones are standing in for pi electrons. We know nitrogen has pi lone pairs of electrons, so these lone pairs of electrons are embedded or involved in the pi electron system. So when you look at the pyrrole, together with these two double bonds and the lone pairs of electrons on nitrogen, so it becomes a conjugated system with 6 pi electrons. That is the same as furan, thiophene. Imidazole also has the same. When you look at the two nitrogen atoms present, one of them will still have the the lone pair of electrons there. So that lone pair of electron is involved in the pi electron system. That is the same as oxazole. So when you look at the 6-membered ring, pyridine and pyrimidine, also when you look at this, these are standard aromatic compounds. Here the lone pairs of electrons on nitrogen do not participate, but we are already having 6 electrons in the rings of pyrimidine and pyridine. So other examples are anilines, whereby anilines, which also will give us the 4n plus 2 rule, will qualify to be aromatic compounds. So anilines, for example, 12 aniline will not be an aromatic compound, but 14 aniline is an aromatic compound, the same as 18 aniline, and so on. Now let's look at examples of anti-aromatic compounds. So anti-aromatic compounds are the ones which obey the 4n. So the difference here is we are having 4n plus 2 pi electron system. Those ones are aromatic. Then the ones which have 4n pi electron system, these ones are anti-aromatic. So when you look at cyclobuta-1,3-diene, it has 4 electrons, 4 pi electrons. Yes, it is planar, it is cyclic, but when you look at the number of pi electrons, they are 4. So when you compare with the 4n plus 2 rule, it doesn't give us the n. The n there will be a fraction, which is not possible. So it qualifies only for the 4n, whereby the n here is going to be 1. So that means it is anti-aromatic. This is the same as the cyclopropenium anion. So the 2 electrons on the negative charge plus these 2 on the pi bond will make 4. So when you look at that, it also gives us a 4n rule. That is the same as with the pentalene, as you can see, and cyclopenta-2,4-dienyl ion, or CP. So it is also anti-aromatic because it only has 2 pi bonds, giving us 4 pi electrons. Pentalene gives us 10 pi electrons, which does not qualify to become an aromatic compound. So when we go ahead, we are going to look at the conclusion. So like we have said before, the only difference between aromatic and anti-aromatic compounds is that the number of pi electrons. For aromatic compounds, these ones obey 4n plus 2, while for anti-aromatic compounds, they obey the 4n pi electron rule. Then we also have non-aromatic compounds. These non-aromatic compounds, for them, they are not planar. That means all their electrons are not on the same plane. So even if it has conjugated or it is not conjugated, by the moment one of the atoms in this place is not sp2 hybridized or it is not planar, then the compound qualifies to be non-aromatic. So thank you for listening and watching. I believe we have learned, and I ask you to subscribe, like, and comment for improvement. Let us meet in my next video, and I remain as Hope Chemist. Thank you.